Hello everyone. In this part, I'm presenting our K-Nearest Neighbors notebook for employee attrition prediction. Section 1 is the introduction and background. We use the IBM HR Analytics dataset from Kaggle, and the task is binary classification. Attrition yes or no. KNN is a non-parametric instance-based supervised algorithm. Instead of learning a global equation, it stores training data and predicts based on the nearest sample. For each new employee report, it computes distance, select the k nearest neighbors, and uses majority voting. We choose KNN as clear baseline because it is simple, interpretable, and works reasonably on mediums as data. We also note its limit, sensitivity to irrelevant features, class imbalance, high dimensional distance issues, and slow inference as data grows. In section 2 is importing libraries. We use pandas and NumPy for data handling, Matplotlib as Seaborn for plots, and scikit-learn component for pipeline scaling, model tuning, and evaluation. Section 3 is loading process data. We use the SMART balance training set and the untouched test set. This gives us balanced learning during training, but realistic evaluation test data. Section 4 is featuring scale. Because KNN is distance-based, scaling is mandatory. Features like monthly income have much larger range than features like work-life balance. So we apply standard scale inside pipeline to avoid leakages. Section 5 is hyperparameter tuning. We run grid search CV with five-fold stratified cross-validation to search for the best distance metric and weighting strategy in section 5.1. The K versus F1 visualization support the chosen setting. Best parameters were Manhattan distance k equals 2 and uniform weights with the best CVF1 of 0.9417. Section 6 is training the final model using the best configuration. Section 7 is test set evaluation. Results are accuracy 82%, 99%, precision 0.4348, recall 0.2128, F1 score 0.2857, and ROC AUC 0.6250. Section 7.1 shows the confusion matrix. Out of 294 test cases, we had 244 correct and 50 incorrect. The key issue is false negatives. 37 levers were missed, while false positive were 13. Section 7.2 is cross-validation sanity checking. Mean CV F1 on training false was 0.9417 with very low variance, but test F1 was only 0.2857, showing a strong CV2 test gap and likely overfitting behavior. Section 8 is error analysis, highlighting the missed levers are biggest business risk. Section 9 summarizes the result. KNN gives acceptable overall accuracy but weak minority class detection. Section 10 gives critical analysis and future work. Strength are simplicity and interpretable. Weaknesses are the cues of dimensionality and no feature import. Improvements include feature selection, PCA, alternate distance metrics, threshold tuning, and ensemble stacking. Future work is direct comparison with random forest, SVM, and XGBoost, then production deployment. That is the complete KNN flow. Thank you.